All right, let's take a look at some of the common sources of error with the magnesium oxide percent composition lab. We start with our sample of magnesium, and this is what we measure as our initial mass of element to calculate our percent of composition for the compound. And one of the questions that you'll be asked to analyze is, what if this wasn't clean? So say that some of your Mg was in fact MgO, because the sort of dull gray coating that you see on top of your magnesium metal if you don't sand it enough is MgO rust. So that's one of our possible sources of error. And the other is, of course, if we have any smoke escaping. So it's hard to see in the still shot from the video, but many of you, when you lifted your lid, even very quickly, may have noticed some smoke loss. And the thing to keep in mind is that when your magnesium ignites, it's converting to MgO, and any smoke that escapes your crucible means you've lost some of your product. So let's think about the calculation that you're doing in this experiment and how both of these could affect your result. So our percent composition of MgO, or sorry, of Mg in the compound is our mass of Mg over our mass of MgO. And our mass of MgO is measured at the end, and our mass of Mg is measured at the beginning. Now, if either of those masses is affected, or affects how much the magnesium oxide converts, it's going to affect this calculation. So with the first question you're asked, which is loss of MgO, if you lose MgO, then your denominator is going to be lower. So when MgO smoke escapes out of your crucible, it means that your final mass that you measure is less than it could have been. So think about, if the denominator of this calculation was lower, that's going to lead to an overall higher percent. So for example, if I take 2 over 4, I'm going to get 50%. But if I take 2 over 5, I'm going to get 40%. And so if you got a lower mass, it's very likely that if you got a higher mass than usual, which is really common for a lot of groups, it's very likely that your lower mass, your MgO product, is a little bit lower than it could have been theoretically. And one of the most common causes that can happen is because there's smoke escaping when you're lifting the lid to try and provide oxygen. Now let's think about the other possibility. What if you started with some of your MgO rusted? So if some of your if some of your Mg at the start was rusted, it means that you thought that this was higher than it should have been. So again, if this was higher than it should have been, because some of what you had in your crucible up here was not in fact Mg that could then be converted and combined with oxygen, but it was already converted to rust. If that numerator, that top number, was higher, the same thing's going to happen. Say that you had 2 over 4, or you had 3 over 4. If the numerator is higher, then that's going to lead to a much higher percent than if the numerator was lower. And so again, for the many of the groups that got a higher percent, another possible contributing factor is if your starting Mg was not pure, and in fact, some of that was already converted, that's going to lead to you thinking in your calculation that the mass of Mg you measured at the beginning, you thought it was pure, but in fact, some of it was already MgO. And so some of it didn't actually convert. And that means that your initial mass, your starting element mass, was a little bit higher. So these are some tips to help you with number 6 and 7, explaining your percent composition. It asks you to talk about how this is going to affect the ratio, or the composition and the ratio. So the ratio is communicated using the percent of Mg. So just as a note, when I say percent Mg, let me just change the color here, sorry. When I say percent of Mg, this is the ratio of Mg in MgO. It's communicated as a percent, but that's in fact the ratio of Mg and MgO. So when it says, how does this affect the ratio? The higher the percent is, the higher the ratio of Mg you're getting in your calculation.